All right, so I think I'm recording. We're taking a look at a semester review for college algebra. Here we're solving a radical equation. This equation has two radicals in it. So with our technique of squaring, we're actually going to end up squaring this equation twice to get rid of this. So we start out with an equation that has two radicals, and we're going to square the left-hand side and square the right-hand side. So let's do that. On the left-hand side, we square it. On the right-hand side, we square it. When you square a radical, that goes away. When you square this binomial on the right-hand side, you're probably not used to squaring the radicals. I suggest you do it in the form of a table, that you have 5 minus radical x times itself. So we've got a 5 minus radical x. So in the body of the table, we have 5 times 5 is 25. We have negative 5 radical x. We have another negative 5 radical x. Negative times negative is positive. The radical x times radical x, the radical goes away. And so on the left-hand side, I just have x plus 4. And on the right-hand side, along this diagonal, I have x plus 25. And along the other diagonal, I have negative 10 radical x. So I need to get that term by itself because it has a radical. So I need to get this term by itself. I need to take x away from both sides. Well, you can see that's going to be nice that these x's cancel each other out. I'm going to subtract both sides by 25. When I subtract 25 there to balance the equation, I subtract 25 there. I get negative 21. I've got negative 10. I can see that I'll just multiply both sides by a negative 1, and it'll change both of these to be positive. But what I'm really going to do, I'm just going to go ahead and square each side, which it would have negative times negative would have changed it positive anyway. So when I square 21, what do I get? Well, I don't want to, I know it's over 400, but I don't want to mess up. 441. On the right-hand side, when I square the radical, it'll go away, but I also have to square the 10, and 10 times 10 is 100. So I have here 441 divided by 100, and I don't believe that that's going to reduce anymore. I can just leave my answer that. I don't see a common factor. Let's check on the calculator real quick and see what it thinks. If I just change it to, it'll probably change it to a mixed number. No? Oh, yeah, okay, so see, it couldn't reduce it. 441 over 100. So I'm going to leave that as my final. No, I'm not going to leave that as my. I need to check and make sure that it's not extraneous. So let's check. Let's come up here and we'll check our answer. We'll use our calculator to help us. On the left-hand side, we've got 441 over 100 plus 4. And I can get a decimal representation for that on my calculator. And the question is that going to equal 5 minus the square root of 441 divided by 100? Okay. Now I can play around and try to simplify that. I'm just going to let the calculator do the work, however. So I've got the square root, and now in parentheses, what do I have? This 441 divided by 100, that fraction, then plus 4. So let's see what I've got. Okay, so it's getting exactly 2.9. On the right-hand side, 5 minus the square root of 441 divided by 100. Hey, it's 2.9, so it is checking, and now I have every confidence that this is the correct solution to that. Hope that helps, and I'll talk to you later.